Okay, I think we are back. Can you hear me now?
Yes, I can.
Yeah,
Let me check in the YouTube channel. Not sure
yeah.
if you checked
According to
already.
YouTube, we are live. Yeah,
Okay, so
yeah, we are live.
yeah,
Finally. Yeah, okay.
yeah,
So,
I can see now.
yeah, let's start. Hello, Rodrigo. How are you doing?
Hello, hi Alan, hi guys. Good morning, good evening, whenever you are watching this one. So nice to be back again. It's quite some time since the last time
Yeah,
we record something.
I think 6 months or more, right? Since last year.
Yeah. I think the last one I was checking here. In fact, I didn't remember, but I was checking the YouTube channel. So the last one, I think, was the GPS. The last time
Yeah,
we
how to use
record.
GPS
So
on NuttX. Yeah.
yeah.
Okay.
So
So,
so yeah. So today we are going to show you guys how to use the barometric pressure sensor. Is BMP 180. Are you sharing my screen?
mm-hmm.
Uh, uh, okay, so let's put the
Yeah, let's see
so
the
yeah.
sensor.
So you are talking about this sensor here, and uh,
Yeah, let's.
we have the specs here.
Yeah, actually,
It's
yeah, I think I need to put this. Yeah, I need to put the screen. Okay, now it will be people in YouTube will see it as well.
okay.
Yeah,
So we are talking about this barometric sensor, and
this is
it's
the
I
BMP 180, right?
yeah yeah yeah. Let me
This
show
one,
the image again. So I don't have exactly this one,
this model.
but
Yeah,
I
this one.
think is very similar. I can show also here. Uh,
Ah,
okay,
yeah,
let me
the
get
the
this
board.
here.
Yeah,
So
yeah, this is
I
very
think
common, right, from AliExpress.
yeah, and you can see that you have this sensor uses the I2C interface. So you have the SDA, SCL, and we are connecting here the power and GND and the SCL and SDA in the in our board's interface here.
Mm-hmm.
Uh, I think it's a very simple
Yeah,
connection, right?
very
We use
straightforward,
this.
right?
Yeah,
Only for wires.
yeah, we used that in other sensors already. And by the way, just to show, uh, maybe uh, just remember the guys about the what we are talking about. So we are going to add support for that sensor, the BMP 180, to this board. So this is a STM32F4 based board,
Mm-hmm.
and we have already ported a lot of sensors for this board and other peripherals. And as you can see here, you're using the I2C one that is exposed by these pins here. And so this is I think it's hard to see, but uh, maybe if I put a little here, you can see the PB7 and the PB8 here, right? So
Yeah, the
this is so this is the board and this is the sensor that we are going to work today.
great, very nice.
Okay,
Yeah.
so let me. Uh, so I think I just synced my fork with the latest one from GitHub, so I have a clean environment here. I will
Mm-hmm.
just make the dist clean here to make sure there's nothing there. Okay, nothing is
Yeah.
configured, so okay. And I think now I will start by configuring using this USB NuttX shell based config. Okay, so uh, let me show you guys something first. This sensor is already supported in your common. So if you go here in the ARMS board, ARMS STM32 common, we can go in source and see that. Oops, I think I already passed.
Yeah.
Yeah, so the BMP 180 is already supported here. So we are going to use the common logic here to to leverage this implementation to our board. And so first, let me configure that, and then I can do the code change. So already configured, and I can do make menu
Yeah.
config here.
When there's some common logic board is very support for some drive, some sensor or other device is very easy, right?
Yeah. So yeah. So basically, I don't need to
In, you don't need to create
implement
an
this.
yeah, a new
Yeah,
file, right?
I don't need to copy or implement this BMP 180.c here because
Mm-hmm.
it's already here. I just need to initialize the sensor in my board, so
Yeah.
it's get a little easy. So first, I think you need to go to system type, and we are going to use
Peripherals.
uh,
Yeah.
yeah, peripheral support because you're going to use the I2C one. So enable that. Then board selection is where you're going to enable the board logic,
Mm-hmm.
the common logic,
Common logic.
sorry.
Yeah.
And now, so now I need to enable the sensor driver. Mm, Let's go to sensors. Okay, almost there. Okay, sensor driver support. And here we have a lot of them. And then need to enable the BMP 180. Okay,
Mm-hmm.
and now I just need to enable the application configuration, examples, and there's an example here.
Cool. Yeah.
So just for uh, just for configuration need to be enabled here. So the the I2C, the common logic, the driver, and the application example. Very easy. I think that's all for here. And now I need to initialize this sensor in my board, right? So let's do
Yeah.
that.
So
So here, I can close here, but here in my board, I have the bring up where we already initialized a lot of sensors, right?
mm-hmm.
And we can do that here as well. So first, let's include the header for this one. You copy from this another board here, the
Yeah.
Olimex board. I
There's
copy from
already
here.
a similar
Yeah,
yeah.
I copy from here. So yeah,
The yeah, the board to port is yeah.
first I will get the the header, and then uh, let's find it here. I think should be easy. Yeah.
Yeah. Then the
Then the
initialization, right?
yeah the initialization itself. Okay. Let's go down and put in the last. Oh,
There's already
I you mentioned.
oh no.
Sorry.
No, no, I was thinking is already here, but no.
No, no. I'll comment another thing later.
Okay,
But
you can
that's okay. Yeah.
comment now if you want.
Yeah, I was just commenting that during this time we added some the GPIO example here.
Mm-hmm,
So if you go, we go here, you have now the GPIO because in the beginning we did a lot of basic things like the LEDs, the buttons,
mm-hmm.
but we didn't part at that time the GPIO.
Yeah, we
Yeah,
talk about
and since
buttons, LEDs, but
yeah,
um, GPIOs we
uh,
didn't show anything.
yes. So now you have the GPIO here. I think I tested a few of them here. Uh, yeah, I need to check here. But anyway, uh, let's go back to our sensor for today.
Mm-hmm.
Uh, I enable I copy here the initialization, and I think that's off
Right.
from code.
Yeah.
Uh,
For
for
the pins that you are using, PB6 and PB7, right?
Mhm.
Is already in the board, in the include board dot h, right?
I
I think
think it's already in the
include, yeah, include,
board. Yeah, because I use it for other ones. So
yeah.
uh,
No,
let
we are
let's
using the
let's
same,
yeah,
yeah, the same I
let's
squares,
double check here.
I square
It
C1.
should be here.
You can maybe search
Uh,
for I squared C1 or,
would be yeah. I think it's should.
yeah, this one.
Okay, so it's here.
Yeah,
It's defined here. And if I think if you go here, you can
can confirm
uh,
if it's PB.
yeah, just need to find the right one here, right? Because there's a lot of
No, just in this line, because it is the just the two. If you move for the, okay, I know
yeah.
what you mean, because this is not for the right STM32. Yeah, yeah, should be this
Yeah.
one. Should be this one that you are selected now
Mm-hmm.
in the
Let me put here.
this PA15.
Yeah, I think it's to get this would be better to go to
Yeah, direct
arc,
arc arm
arm,
source
uh, source,
STM32
and
hardware inside hardware
hard,
STM32. Um, now is the pin map for yeah STM32 F4. Yeah, this one. Maybe not
yeah.
I'm not sure if legacy, but yeah, maybe legacy because it's not converted. Yeah, this one. Yeah,
So
PB8 and PB8 and PB6 or PB8 and do you remember?
is PB18 PB? I can see here in the label is PB8 and
Yeah, the
PB7.
okay. PB8 is confirmed, and now the other should be I square SDA1, right?
Yeah. So
Yeah, the third line
yeah,
in this block. Yeah,
PB8 and PB7.
yeah, that's correct. Okay,
So SCL2 and SDA1.
yeah, it just to people see uh, that we are using the right I square C, right?
Hmm.
We can
So
just to
if you
confirm
get
there's no
back
mistake.
there,
Yeah, so
so yeah, so
yeah,
SCL2,
yeah, maybe later we can put some comments in after the line, like in
yeah,
um,
yeah, I think it would be useful because
yeah,
then the guy don't need to go to
yeah,
the arc
yeah. But
and do what he did
this
now.
just curiosity. Yeah,
Hmm.
we don't need to do that for now. And
Okay,
yeah,
So I think that's all for coding, and
Mm-hmm.
let me
Yeah,
uh,
like make
let's make it.
make the show and
Yeah,
make it happen.
let's just change the. Just a second.
Very cool.
Okay,
Yeah,
it
that's
should
great.
be. Let's.
Yeah, I think
Uh,
we almost explored everything for this board, right? Except for the
yeah,
GPIO that um, we didn't create a video about it, but except for that, all the peripherals we
yeah.
explored.
We did a lot of things.
Yeah, cool.
Okay, so are you putting
DFU mode.
the fuel mode by pressing boot and reset? Oops,
Yeah, the LED need to
boot
turn off.
and reset. Yeah, I
Yeah,
released the boot before releasing the reset, so like
yeah, the
this
opposite.
way we. So now I'm going to use the DFU to flash. So let me do that here. You ask for my.
Hmm. Yeah. The good things about this DFU is very fast, right? We don't need to use
Yeah.
external SWD programmer and nothing else. Just
Yeah, so you know that I have been playing with some CD Studio shell boards,
yeah,
and you have different vendor ships there. There's Renesas, there is
yeah. Renaissance,
uh,
expressive, many
yeah,
uh,
and
Raspberry Pi Foundation. Yeah.
yeah. So the some of them I need to copy the file to as a storage device. I think it's UT U2F or UTF file.
Mm-hmm.
And then when I copy the file to mass storage, they flash the firmware and reboots the board. So uh, this way here using DFU is very fast. I just put the board in DFU
Yeah.
mode and flash.
Exact.
Okay, so let's go back here.
Yeah. Reset and let's
Okay,
see if
the
the
board is,
NuttX
and let's
terminal show up.
go here.
Yeah.
Let's just get the timestamp here. So
Yeah.
is
It's today.
today, and we did this just right now, right? So now is around this time here, and we can see the application was here, is here.
Yeah.
Let's check the dev.
Yeah. Slash dev.
We have here the press 0,
Yeah.
and now let's read that by running the application. Oops, one,
BMP. Yeah.
yeah. Okay,
Cool. Yeah.
uh, so let's see. Pressure 93, sync 9. Okay, 5.
You know, if you are like in in a big building and you have some, I don't know, like fast Wi-Fi and you can move up, you can see this value change. But for now, I think they're okay because the value is near the same range, right? Is just a
Mm-hmm.
small variation.
Yeah, let me. I just trying to get the information.
Hmm. How to convert it to pressure, right?
Uh,
Mm. I don't remember how to do that.
Let me Google here. Pressure.
Maybe do you want I change the camera? No, okay. You are in another.
Yeah.
Okay, don't worry. Let's see.
So I'm trying to get here the. Okay, so I think I got something here. So I'm in this city, right? Campinas,
Mm-hmm.
and my the elevation for my city is 680 meters, and I put the value. Uh, I put the value that you are reading there,
Mm-hmm.
and got 664. So so it takes the temperature as consideration. Have now 23. Let's see if it will change something. Yeah, so
Definitely
very
very
near
near
to the
the elevation for Campinas.
yeah, yeah,
Yeah, very, yeah. Maybe, yeah, only 2 meters because this elevation is a average, is an average between
yeah,
many places in the city. So probably you are two
hmm
meters above the
yeah.
average. Yeah, cool, really nice.
Yeah. So that's yeah. So that is
Yeah,
how to use this sensor. I think this sensor has other uh,
other alternative like using UORB, right?
yeah, yeah. I have never used it. Do you think
Yeah,
we
if you
should
want,
try that?
if you have time, yeah, maybe in 10 minutes you can do this test. I also never
Okay,
do that, so maybe you can do it for people see. Yeah,
let's see if we can do that. So uh,
yeah,
so in the I have never used the warp.
yeah. There is a sensor test that we need to enable after enable the micro orb for for this sensor. Yeah.
So first you enable the driver, right? For
Mm-hmm. Inside the driver, there
so
is an option to enable the, yeah, this one,
this
U
one,
orb interface.
okay. UARP interface.
Mm-hmm.
And
Now we go back
do
in
we need to
applications and search
go
for,
back?
I think it's sensor test or something like that. Mm, not, I think not in example. I think it's like in, there is a new place to
Let
it,
me
like sensors or something like that.
testing.
Yeah,
No.
let's see if we find sensors. Uh, let's search for sensor
hmm
test. If you
Test.
choose everything together, but okay.
Okay. Yeah.
Yeah,
System sensor
systems,
test.
inside system libraries and add-on. Just press the number one and go straight to
Yeah.
that. Yeah, this one. Yeah, you can, maybe you can change the name, just sensor instead sensor test, because a big name, right?
Okay.
Just sensor. Yeah,
And
yeah.
okay.
So after
So
that we pass the, I think we need to pass the type of,
uh, uh,
I have here the, let's see my blog. I think I test some sensors in the past. Let's double check here.
okay. I was thinking about the code because
No,
is this
I think,
applic
anything else not change.
okay.
The process, I think the process to register is the same.
Okay.
Yeah. Okay, I think now we can we can leave and just try to compile.
Okay,
Let's see.
okay, okay. Just need to, yeah. Let's save. Let's make again.
I'm fine here. There's a sensor test. Yeah, basically just for example for barometer, you just type sensor test baro zero probably. Yeah, maybe okay. Yeah,
Okay, let me flash. We can try to.
yeah. I'm just trying to remember if the function name in the driver change, but I don't think so. Maybe it's the same function. By the way, we can just before we run the sensor application, we
Mhm.
just need to look inside the slash dev uorb.
Okay, so let me reset the board,
Mm-hmm.
and now I go back here.
Okay, slash dev.
Let's see. So we have the press zero, and
Mm,
the sensor said, what's the command?
no, actually should be sensor test or sensor in our case.
Mhm.
Baro zero for barometer. Um, just
Uh,
o-
Let's
okay.
do. I think I see this code some time ago when I
Yeah,
check some.
it exists for the ESP32. If you go inside, yeah, if you go inside the STM32,
Just a second, I will go there. Just want to check here the.
maybe,
Okay.
yeah, no, I think the point is the board initialization. Maybe
Mm-hmm.
it's different because you need to initialize a sensor like a UORB sensor. Look inside
Okay.
the board,
Okay. So board. Sorry.
extensor,
Ah, extensor.
yeah,
Okay. Let's. Okay.
and extensor STM32 um, dev kit,
Mm-hmm.
this one, source, okay, and bring up board and search for uorb maybe or barometer. Yeah, uorb. Let's see, nothing.
Oh,
Barometer.
sorry.
Yeah, let's see. Uorb.
No.
Search for
Okay.
yeah. Um, Basically, this is the same, right? That you are using.
Yeah. I think it's in common, right?
Yeah,
I think that.
yeah. Could be in common, and for example, if you define uorb, it could call.
Let's see if you have something. Okay. This BME
Yeah, you need to
here.
register this one exactly.
Yeah.
But there is no nothing different, right, from a normal
Yeah, because it
registry.
seems that uh, the driver is already. Maybe the driver for this one is already registering using the UARP. So I don't know if you are able to use the BMP180 without
Um,
changing the driver.
I know what you need to do
Okay,
because we need to clear the previous compilation, right? Maybe try to run um, make it clean and then make apps underscore this clean in the source code.
because
Yeah.
Okay, do you want to clear the configuration?
No, go back
Okay,
to this. Yeah. Try
okay,
to make clean dash J.
okay.
That's
Sorry, dash
J
J.
like
Okay,
DJ. Yeah.
okay.
Okay, and make apps,
F's.
apps, like application, apps,
Oh, apps. Oh, sorry, apps.
apps
Okay,
underscore, this underscore, this clean.
okay.
Yeah. Okay, let's go.
So this one is new for me.
Yeah, for
This
me,
command.
yeah, I also didn't use UOB too often because it's a new way to create to use sensors, but they are
Okay,
more sophisticated. Let's put this way. Yeah, but
and now, yeah.
yeah, and now just type make space dash j. Let's see
Okay, just
if you not
recompile.
yeah if it's not make difference. We need to look the driver for the BMP 180 and 80 and see if there's some difference or
You see something change. You see?
what.
Uh,
Oh yeah, you need to exactly you need to replace it, right? Yeah,
yeah,
exactly. See the difference
yeah,
before doing this make clean, it accepted because it was precompiled in some way. So I think we find a way. We discover some issues that need to be fixed.
yeah.
Yeah,
So let me replace that. Oh no, it's not here.
I think is that
Is it here?
yeah. So
BMP
just suggest to
register.
use exactly BMP exactly BMP
Oh,
register
in fact, is in not here in the
in the board,
initialization, but
right?
in the board. Yeah.
Yeah,
So I need to go to common source
yeah.
and go here.
Actually, we need to have like if def, right, to have these two options.
Yeah.
But for
I'll
now,
put, I'll, I'll pass this here just for testing now, but
yeah,
we can
we can fix it.
later change that for.
Yeah,
So in fact, so I need to put this if def based on that
yeah,
configuration in
yeah.
the
But and also you need now open this BMP 180 register to see what are the two parameters. I think the def path need to change as well, or maybe
device number
yeah,
and
def
I2C.
exactly. We don't need to pass the path anymore. So you pass zero there, zero because the first one and the I squared C, just that.
Okay.
Yeah,
Yeah.
probably it will create a barrel zero, like a barometer zero. Cool, very nice. So we discover a good thing, right? Now we know how to use it in the board.
Yeah.
Yeah,
Let me
yeah,
try to build again.
yeah.
Mm.
Oh, it compiled, but we need to enable work queue. Make menu config and let enable it.
Okay.
This is very important thing that people need to know.
Work.
No, I know where you don't need to type
Okay.
it. Go to system type.
System type.
No, sorry. No, go back.
Okay.
It's not in RTOS features. Work queue. Move the down.
Okay.
There's a work and yeah,
Okay.
work queue. Just enable this work queue thread. Maybe
So
yeah you can enable the low priority because we don't need to be high
okay.
priority. Exactly. Just that.
Okay.
Cool. Let's
So
see.
this, what is this work queue?
Uh, work queue is used when you have, like, for example, we have an interrupt,
Hmm.
and we don't you cannot do so much work inside the interrupt. So use a work queue to do it after the like create a thread to run after the interrupt happen. Understand? Like
Yeah.
something that's not stopping the interrupt for much time, because if you keep running, for example, some complex thing inside the interrupt uh, routine, interrupt safes routine,
Hmm.
your system will be unpredictable. So for a real-time system, it's not a good thing.
I see. Yeah.
Yeah.
Okay. So the build was successful, and now I
Go to flash again.
loading the board and just reset the board. So let's
Yeah.
see how
Let,
it's okay. The sensor is there. Let's see the dev.
now you have
Okay.
U orb, and if
Yeah.
you slash U orb, you see there's some barrel zero or something like that. Yeah, sensor barrel
Sensor.
zero.
Uh,
Cool.
okay.
Now just type sensor space barrel zero,
Okay.
barrel zero, barrel zero. Yeah, cool. Oh, see, it's not showing the value because there's no float point enable. That's something
Mhm.
very sad. I think this kind of thing should be enabled by default. But okay, we can enable it. So
Let's go.
here we go again. Yeah, I think we do it in 2 minutes. We are spend 10 minutes, but okay, now we run a new
That's
thing.
okay.
Yeah,
And is
library
library
routine.
routine?
Yeah,
Yeah.
go S. I think that stdio, or there's something. Do you remember? I think it's inside stdio library or something like that. It's in the beginning, not in the end.
So let's go back here.
I think
Uh,
more
Standard CIO.
standard or here or in standard lib. Okay, go here first. Yeah,
Okay. Here.
floating point support. This one.
Okay.
I think this the kind of thing that should be enabled by default on NuttX. I don't know why it's not.
Mm. Yeah.
Maybe for deep embedded system it should, but in our case, at a normal board, it should be enabled by
Mm.
default.
I put the board in flash mode again.
Yeah,
And
cool. Yeah, and later we need to fix that legacy because we are still using legacy pins. But for
so
now,
let's.
okay. Let's see.
o-
Now we can see the problem. Now we will see the floating point values.
Okay. So let's reset the board.
Go to
Go back here.
okay,
And I think I will try straight
straightforward.
the.
Yeah, barrel zero.
Yeah.
Cool.
Yeah.
See that?
Now we have
Two
two
values.
values, right?
Yeah, because I think this BMP 180 180
Hmm.
report the two variables. It export the pressure and also export the temperature.
Yeah. Uh, and
See,
okay.
the value is very similar to the preview that you are using. Yeah, you can go
Mhm.
maybe in sensor better and see what is the second. Yeah, exactly.
The
Pressure
first
and
one is the
temperature.
pressure and
Yeah, and
temperature.
temperature. So
Maybe Fahrenheit or
yeah,
some. No, I think.
if I was trying to say some bullshit, you could prove I was wrong. But this time I was I was not. Yeah,
But I don't think it's.
Yeah,
to
probably this value is like you should read it like 23.2, something like that, because this integer convert.
Oh, yeah, yeah, yeah. That makes sense.
You can, yeah,
Because
you can put your finger over the sensor, and the temperature should be near, after some minutes should be
yeah,
near to,
yeah,
you did it
few
right, we
seconds.
can see it
Yeah,
increasing. Cool.
yeah, few sec.
See that?
Yeah,
Yeah, cool.
yeah. Okay. So
Yeah,
that makes sense. Just a matter of formatting here,
yeah,
the
yeah,
point,
because it is
because
just, yeah,
it's too hot for.
yeah. See, the value actually is not floating, is integer converted to float, I think.
Yeah,
Because see,
and,
for the pressure we have the decimal point, but for this one there is no decimal point.
yeah.
Yeah, cool.
Okay, cool. So we did this. So very interesting to learn this.
Yeah,
Uh,
yeah, and
another
I
way
think it
to.
will be useful for many people facing similar issues like we did today in NuttX, right?
Yeah, yeah.
Yeah, I think it's important to have this kind of live in demonstration to people
Mhm.
see how to do things, and because sometimes when people don't know how to solve the issues, some people give up, and we can show they don't need to give up. They can prevail. They just need um, to study a little bit more to understand how the
Mhm.
system works. And also,
Yeah.
yeah, and also NuttX need to be better, right? And we can, like, this floating point is something that we can enable by default in the future.
Yeah, great. So this is a very simple sensor, but you see that you can learn a lot of from a simple sensor, right?
Yeah, many things to learn.
Okay, so uh,
Thank you,
I
thank
think
you, Rodrigo. You did a great job today, showing this sensor, how to use it, and we go a mile, extra mile, right? Showing how to use the
yeah, yeah.
micro.
Thank you for your guidance here, your support. So so if without you, I will stuck in the first part. So thanks a lot.
Oh,
And
my pleasure,
now
man.
that you are back, let's plan for the next.
Yeah, and let you keep doing more often like we used to do, some last year, in the beginning of next year, and yeah, it will be
Great.
great to.
You have sent some interesting displays for me, so let's try to do something with this display next time.
Yeah, I think we can show how to use some LCD display on NuttX, how to use LVGL. Should be really cool.
Great. So see you guys in the next one.
See you guys. See you, Rodrigo. Thank you very much again.
Thank you.
Really good,
Thank you.
really good demonstration. Okay.
Thanks a lot. See
See
you.
you
Bye
guys.
bye.
Bye bye. Okay. Stop streaming.